This is test number 15 regarding the part 1 of circular motion.
So the first question, average speed of a particle which moves 5 rad within 1 second in a circular path with radius 1 meter is, right? So they have given 5 rad. So 5 rad is 180, right? So that is, they have given that as an angular displacement. So the angular displacement is this much. So they say that is 5 rad. And this motion is done within a 1 second. Within a 1 second. And they also have given the radius, that is 1 meter. So the motion is along this path, like this. So what they ask is average speed. So what's the equation to find average speed? Average speed. Total distance, right? Not displacement, distance divided by time. So what is the total distance? This much. So that is half of a circle, right? Half of a circle. So 2 pi r is the full circle. Then you have to divide that by 2. So you get 5r. So 5r means here the radius is 1. So the total distance should be 5 times 1. So you get that in meters. Then divide that by time. Time is a 1 second. So you get 5 meters per second. So this is the average speed, right? Let's say they ask average velocity. So you need to have total displacement divided by time. So what's the total displacement? Displacement means shortest distance between the end point and the beginning, right? So the shortest distance is 2 meters. 1, 1, 2. Time is 1. So if they ask average velocity, you get 2 meters per second. But if they ask average speed, you get average speed, you get pi meters per second. For the average velocity, you get 2 meters per second. So it is a difference between distance and displacement, right? Anyway, the answer is this one. So the answer should be second one there, right? So I have to correctly understand what each term means. So in that question, those terms are important, right? 5 rad means, that is, they have given in terms of angular displacement. So linear displacement is 2 meters, right? Distance is pi meters. So you have to clearly understand the difference between those terms. Right, moving to the second question. They say 2 cars with masses m1 and m2 move in circular paths, radius r1, r2. If both vehicles take equal amount of time to complete one round, what does it mean? Time periods are the same for both. Ratio between their angular velocities is, right? So what's the equation for angular velocity? 2 pi divided by capital T. Okay, angular velocity is 2 pi divided by capital T. T being time period. Capital T is the time period. Right. In this equation, we don't have any terms for MOR. Right. So meaning of that is omega is only dependent on capital T here. Right. If capital T is the same for both, then omega also should be the same for both. You don't have to worry about mass and radius. This is important, right? Then another equation, 2 pi 1 over t is frequency. This is extra fact for this question, not for this question, but it is important to understand this. So this is 1 over t is frequency. So you can have 3 types of equation for omega. One is in terms of time period, another one in terms of frequency. So if they say one of this is a constant, frequency is a constant, time period and omega also should be constants to this, right? So in like MCQs, they check this. If they having the same time period, you cannot have a different omega or a different frequency. So these equations, they are saying about the same thing in different forms, right? We don't have any other variables here, only omega, t, and f. So they are talking about the same thing regarding the motion, right? So remember, if they say one of these is constant, automatically you have to think that frequency and omega also is constant. Understood? Right. So they said same time period. If it has the same time period, omega also should be same. So what should be the ratio? Should be 1:1, right? When you divide by omega. Fourth one's the answer. Right. Third question. Change of velocity of a particle moving with uniform speed, not velocity, speed, right? V in a circular path when it makes pi over 3 rad is. So pi over 3 means 60 degrees, okay? 180 divided by 3, 60 degrees. So for the convenience, I'll draw that path like this. So you can easily deal with vectors to get the equation. You can draw it any other way as well, but if you get one of this one horizontally, it will be easy, right? So you can see these two angles are 30 degrees. And they say speed is v. We cannot have a uniform velocity along a circular path because direction changes always. But we can have a speed. So here the speed is v to this side. You know that it is perpendicular to the radius, right? At this point, velocity is perpendicular to the radius. Then I can make this drawing, just extend these lines. Okay. So let's say this point is 1, this point is 2, right? So what they ask is a change of velocity. So from this question, you can understand why they say centripetal acceleration is always towards the center, right? Let's solve this. So what they ask is change of velocity, right? So delta V, so that is V1, final velocity this one, initial one this one, V2, right? But this velocity, they are, even though they are the same, directions are different, right? To this direction minus to this direction. Okay. Since the directions are different, you cannot simplify and say this is 0. You need to think about vectors, right? Right. There are many ways you can do this, but I'll just resolve this vector. Resolving means breaking it into its components. So if I break this one into components, you can understand that this angle 30 and this angle is 60 degrees. Right? 90, 30, this should be 60. Then I'm getting this component. So this is, it should be V sine 60. And the component is upwards, right? Plus, I'm still dividing this one, right, into components. Plus, then this component along here, V cos 60. That its direction is to this side. You need to include the directions. Okay, I have resolved this vector into these two components minus this one. So how do we get there? If you divide it into vertical component, V sine 60, right? It is upwards. If I can draw this, write this. Previous component V cos 60 to the center, right? Then this component to this side. So you get V cos 60. So what do you get? For this component, you get V sine 60 upwards plus V cos 60 to this direction. Okay. Now I have resolved both vectors, velocity vectors into their components. Right. Then you can see that this v sine 60 and v sine is same direction, and there's a minus here. So you can cancel these two, right? Then what do you end up with? V cos 60 to this direction minus v cos 60 to opposite direction. Okay. V cos 60 to this direction. Then you can make it minus minus plus v cos 60 towards the center. Now they are to the same direction. You can just add them. So what do you get? 2v cos 60. So what's the value of 2v cos 60? I mean cos 60 is half. So what do you get? V. Got it? So that is the difference. And the direction is towards the center. See that? The velocity directions are to these sides, but when you take the difference of velocities is towards the center. Right? So this clearly explains why centripetal acceleration is always towards the center. To find the centripetal acceleration, all you have to do is just divide that by time, right? So when you divide that by time, you get the centripetal acceleration. And that also should be the direction of difference of velocity, right? Okay. From this also you can see that these two components cancel off when you subtract. And when you subtract this one, this arrow turns to the other side, it becomes 2v cos 60. 2v cos 60 means v, right? So when you are learning circular motion, this is a really important concept to understand, right? You must understand this. Then only you will understand why they say centripetal acceleration is always towards the center. Correct? Right. Fourth question. Tangential velocity v of a particle moving in a circular path of radius 50 centimeters. So they say the radius is 50 centimeters, meaning 0.5 meters, right? And they are saying it is not it doesn't have a uniform speed. They say that speed increases with time. If you say 3t with time, speed increases. So in those cases, there's a tangential acceleration as well, right? If the speed is constant, tangential acceleration is 0. There's only a centripetal acceleration. But in this case, there's a tangential acceleration as well, because speed changes, not velocity, speed. Velocity also changes, right? What they ask is find centripetal acceleration of particle when t equals 4 seconds, right? So before that, let's find velocity at that point. I mean speed at that point. So when you substitute it, 3 times 4, so you get 12 meters per second, right? So in this moment, velocity is 12 meters per second. They have given, right? Right. So what do they ask? Find the centripetal acceleration of particle. They are asking about only the centripetal acceleration. So acceleration to this side. So you can have this equation v squared over r. This is the equation for centripetal acceleration. Since they have given v, I just use this one. If they have given omega, use this one, right? R omega squared. Then there's another equation, velocity times omega, right? You will need to use this as well in some rare cases, but these three are the same equations, right? V squared over R omega squared, V omega. But in this case, I'm using this one, V squared over R. So V is 12, R is 0.5, meaning half. 12 times 12, 144. This half, instead of this one, it is half. It goes up, flips, becomes 2. 288 meters per square second. So the answer is fourth one. Right. Fifth question. An astronaut who is sitting attached to end of a horizontal bar. Let's say this is the horizontal bar and there's the astronaut with length 5 meters is rotated in a horizontal circular path. So the horizontal circular path, right? For a space exercise around axis through another end. So they say it rotates around this axis, another end. Is the maximum acceleration that astronaut can bear is 8g. G means 10, right? Maximum rotational velocity that the bar can be rotated in the radians per second. I mean, without damaging the astronaut, you can rotate the bar, right? So like for like astronauts and jet pilots, they face really severe accelerations, right, as they are moving. So before that, they are exercised whether to check to face those large accelerations before just putting them in the jet or a rocket. So that this is a similar exercise. They use this method, right? Mainly they use this method. So you can easily accelerate, give them accelerate towards the center with just by rotating a rod. So it is a convenient way to provide accelerations in a simulated environment, right? Okay. So like they said it is 8g for this astronaut, it can hold 8g. So it is 80 meters per square second. So that's the maximum acceleration he can hold. Right. So centripetal acceleration. So here in the question they ask maximum angular velocity. So I'm using this equation r omega squared max. Okay. Right. So the radius is 5, 80 divided by 5. You get omega squared 16. So the omega max should be 4 rad per second. Right. So you can rotate this rod at this angular velocity in order for the astronaut to feel this much of a acceleration. So he feels that acceleration. Correct? Right. Sixth question. Which is the graph that shows combination between angular velocity of a particle and centripetal acceleration? This is an easy question if you know how to deal with graphs. So what is that angular velocity? So let's say the equation is a r omega squared. So they say y-axis we have centripetal acceleration and x-axis we have omega. So this is y equals r, kind of like r x squared, right? So this axis y, this axis x. So what do we get? So if you get a question like this, when x is 0, you can see y is 0. Y is 0, right? When x goes to infinity, y also should go to infinity, right? If you draw the graph like this, you can see as the x goes to infinity, y goes to a certain value. It cannot happen, right? So the shape of the graph should be to this side. Not like this. So it should be like this. You can see as x goes to infinity, y also goes to the infinity. So the shape of the graph should be like this, right? So it is clear that this cannot be a linear graph. This must be a non-linear graph. But some students struggles with whether to choose this graph or this graph. But you have to understand that this graph goes to a certain value in y. But here, according to the equation, when x goes to infinity, y also should goes to the infinity, right? So the answer should be fifth one. Right. Seventh question. A particle moves in a circle with radius 10 meter. So the radius of the path is 10 meters. And its speed increase at rate 10 meters per square second. What does it mean? Every second the speed increases by 10 meters per second. So meaning of that is they have given the tangential acceleration. So that is 10 meters per square second, right? In most cases, you get, when it comes to circular motion, in most problems, this tangential acceleration is zero, right? Meaning you have a constant speed. There's a centripetal acceleration for any circular motion. There must be a centripetal acceleration. But for most of the questions, this AT is zero. Tangential acceleration is zero. But here they have given tangential acceleration. What they ask is angle between tangential velocity and resultant acceleration when the velocity of the particle is 10 meters per second. They say in this moment it has a velocity that also is 10 meters per second. You can see that this velocity is tangential velocity, right? That is 10 meters per second. So what they ask is angle between tangential velocity and resultant acceleration. So what is this resultant acceleration? So you can see at this moment we have a centripetal acceleration. First let's calculate that. I'll use v squared over r. V means velocity they have given 10. Radius is 10. So the resultant acceleration also you got 10, right? Right. Then from these two, you have now two acceleration for the same particle. So the tangential acceleration should be to which direction? It should be the resultant of these two acceleration, right? And let's say that I'll just draw that difference. So you have 10 tangential acceleration, centripetal acceleration. Then here you have the resultant acceleration. So you can see it should be 10 squared plus 10 squared root. So which is 10 root 2 meters per square second. So what they ask is this angle alpha. So it is obvious this tan alpha is what? 10 divided by 10, which is 1, right? So alpha should be what? 45 degrees. Alpha is 45 degrees, right? So this angle is 45 degrees. Okay. So that is the, so there are like in this question, there are three types of accelerations. You clearly have to understand these terms, right? Tangential acceleration, centripetal acceleration, and there is resultant acceleration. This resultant acceleration is towards the center in most cases, given that tangential acceleration is 0. So you need to clearly understand the difference between these terms. So not understanding this is the reason why you find these questions difficult. Right. Eighth question. A mass m moves in a horizontal circle. So the circle is horizontal. Angular velocity omega and radius r. The work done when the mass goes 2 rounds in the circle is, so it goes 2 rounds. Okay. So what's the equation for work done? Force times displacement. But do you remember that in order to do a work, there must be a force to this side and there must be a displacement, right? To the same direction of the force. But if you think about centripetal acceleration, which has uniform omega, right? Uniform omega, constant angular velocity. We don't have acceleration to this side. So the acceleration is only the centripetal acceleration. Meaning of that is force is towards the center always, given that omega is constant. What can you see? So the velocity is this side. So the direction of the displacement or the movement is always perpendicular to the direction of force. So it is always, if you go here, force is like this, displacement is this side. Always perpendicular. It's like this, right? So the displacement is to this side, but the force is to perpendicular. So can a perpendicular force do work given that displacement to this side? No, right? So it is 0. Understood? So you can see that given that for uniform velocity, the work done by the centripetal acceleration is 0 always, right? Not centripetal, I mean centripetal force. Centripetal force is 0, right? Right. Ninth question. What is the force required to move 0.8 kilogram of mass along a circular path with radius 0.7 meters within a time period 0.5 seconds? 0.5 seconds means to complete the one round it takes 0.5 seconds, right? And also they say take 5 squared closer to 10, right? Right. So what they ask is force required for this, centripetal force required for this. So in order to move this in a circular path, we need a centripetal force. Right. So you can just apply F equals ma towards the center, which you always have to do, right? Okay, so the force is centripetal force. Mass is 0.8 times acceleration. Acceleration, you can find that using this one, r omega squared. Okay. So let's find the value. So r is 0.7. Omega is, you can say 2 pi divided by time period. Time period is 0.5. Square of this. 0.7 times 0.5, take it to the up, right? It flips. So this half becomes 2. Then 2 times 2, 4. 4 pi. 4 pi squared. 0.7, 4 squared means 16. Then you get 5 squared. 0.7, 16. For this question, they have given 5. You can take 5 as 10, right? 5 squared. So 10 times 0.7, 7. 7 times 16. What do you get? 42, 111, 112. So this is the centripetal acceleration. Just substitute it here. 112. Then just multiply this by 8. So 16, 9, 8. You have one decimal. So it is 89.6. This is the required centripetal force. Centripetal force. So this test is not that difficult, right? But you have to, the main focus of this test is to clearly understand the concepts, fundamental concepts behind circular motion, right? Okay, we'll do 10th question. A particle with mass m goes in a circular motion and the radius is r. They have given momentum of the particle. So momentum is mv. If the momentum of particle is p, radial force acting on the particle is. Radial force also means centripetal force. So what's the equation for that? M v squared divided by r, mass times acceleration, right? So we have to convert this into one of the forms in the equation, right? In the answers, they have given P, R, and M. What we don't have in the answers is V, right? So you need to get rid of V. There are other ways, but easier way is to just multiply denominator and numerator by M. So you get M squared V squared. Here you get MR. MV means P, right? So you get P squared divided by MR. So do we have an answer? Yeah, fourth one, right? P squared divided by MR. So you have to clearly understand in the answers, none of the answers have V, right? So you need to get rid of V. Other ways, you can subject V and substitute it here. Then you will have the same answer. Right, 11th question. If the resultant force acting on a particle moving at constant speed V is capital F, linear momentum of it is, right? So it is constant speed V. So we don't have a tangential acceleration, right? So not tangential forces as well. Only force is towards the center, which is the centripetal force, which also is the resultant, right? So they say it is F. So the normal equation is this one, right? M V squared divided by R. So what they ask is, in this case, what they ask is linear momentum. So if we check the answers, in the answers we have F, R, and V. What we don't have is M, right? So you need to get rid of M. How do we get rid of that? P equals mv. So m is momentum divided by velocity. Just substitute it here. Instead of m, put momentum divided by velocity. Right? Instead of m, you can use momentum divided by velocity. Then there's v squared. This v cancels off. Then you get, sorry, this is not v, right? This is r. Okay. So that's why you need to clearly write these terms, right? Otherwise, when you are doing it accidentally, you might do a wrong calculation there, right? So this is not so the answer is PV divided by PV squared divided by R. Sorry. Let's start from the beginning. So here we have mass times V squared divided by R. So instead of mass, you can substitute momentum divided by velocity, not R, right? V squared divided by R. So this V and V cancels off. You get PV divided by R. Okay. So in terms of momentum, velocity, and radius, centripetal acceleration you can get from this equation, right? You don't have to remember all these equations. Just quickly derive the equation required. Here not they're asking about P, right? Linear momentum, not F. So you need to subject P, right? So cross multiply FR divided by V. FR divided by V. So that is the answer, right? Third one. Right, 13th question. One end of a string is attached to a mass, simple M, which is on a smooth horizontal table, and other end is attached to a mass, capital M. Okay, here you have circular motion and there's a punch here. Then through that punch, let's say that is smooth, no frictions. There's a mass attached here, that is capital M. And this is moving at, let's say, velocity v. Find the tangential speed required to keep the mass capital M at rest, right? So here you have the string like this, right? So if I mark tension for this circular motion, tension is what causes the centripetal force. So you can see the same, given that this is a smooth here, tension here also should be T, right? So this tension is built because of this circular motion, right? In order to keep this one, you need to give this a circular motion. So in that way, tension is created. So this tension have to balance the weight of capital M. So this will be at rest. So this simple M keeps rotating. Right. So from this one, you can see that tension is equal to mg, right? It is at rest. It is in equilibrium. Tension is equal to mg. Here also it should be mg. Then, as usual, you have to do what you have to do is just apply F equals ma towards the center of the circular motion. So center is this one, right? Right. Let's apply that. So you can see tension is T. That is the only force towards the center. Mass, there's a simple m. Then the acceleration. Since they are talking about tangential velocity, I'll use v squared over r. Right? Then we have seen that tension is equal to mg, capital M. Right? So what they ask is tangential velocity, v. Then all you have to do is just subject v, right? Take this to other side, m g r divided by simple m is equal to v squared. Then take the root. So v is equal to mgr divided by simple m root, right? So this is the tangential velocity. mgr divided by simple m, take the root, right? 14th question. 14th question. 0.05 kilogram of mass is attached to the end of a string with non-extended length 0.5 meters. So 0.5 meters, this is non-extended, right? We haven't applied any force. So meaning of that, this is a elastic string, right? So the mass attached is 0.05 kilogram, right? Then they say force constant of string, that is K, 40 newtons per meter. So you know that this is the equation, right? F times K extension X. This gives us the tension, right? Built in the string. So the mass moves in a horizontal circle, horizontal table, on a horizontal circle, which is horizontal circular motion, right? Radius they have given at a 0.7 meters, right? So what does it mean? Extension is, now the string is, since you are rotating that in a constant velocity, now the extension should be 0.2 meters, right? Because it has extended to from 0.5 to 0.7. So the extension amount is 0.2 meters. So you can substitute it here, K is 40 and 0.2 is the extension. Then you get 8. 4 times 2, 8 Newton. So 8 Newton should be the centripetal force or the tension built in this extensible string, right? So this is not non-extensible. This is a this is not an inextensible string. This is an extensible string, right? So the extension is 0.2. So we have a 8 Newton of tension, right? So the difference is for extensible strings with the extension, tension increases proportionally. Right. Now we know the centripetal force, radius, and mass is 0.05 kilogram. So what they ask is, in order for these to happen, tangential velocity. You just have to use this equation, right? F equals mv squared divided by r. So the force is 8, mass is 0.05, v squared divided by r is 0.7. Okay? Just multiply like this, 8 times 0.7 divided by 0.05, v squared. So you can see that 8 times 7, 80, 56 decimal here. So you get 5.6. 0.05 is what? 0.5 is 1 over 2, right? So 0.05 should be 1 over 20. So instead of this one, you can use 1 over 20. If it goes up, it flips and multiply by 20. So when you do that, you get multiply this by a 10, 56 times 2. What do you get? 112. So v squared is equal to 112, right? Then you have to get the root of that. So in the question, what they ask is an approximate value, right? They're asking about an approximate value. Then you have to find v, then get the approximation. So to find v, you can use a logarithm, so those stuff, right? Don't shy away from using logarithms, right? So the only calculator available in the exam is the logarithms, right? Even though I'm not going to do it, it's your responsibility to do and practice these logarithm calculations, right? It is the only way you can go around a complicated calculation, right? 15. Two objects with equal mass are attached by light string, right? Equal masses, it's same, and this light string. These points, they say A, B, and C. This is an exam question, right? And they say the radius here is r, and the radius of large one is 2r. They say the tensions here is T2, here T1. So you can see, since there's a mass in between, the tensions have changed, right? Even though this is a light string, we don't have the same tension in each part because there's a mass attached in the middle, right? So we have different tensions in each part, right? So what they are asking about is equation or combination between these tensions. So as usual, just apply F equals ma towards the center, right? That's all the time. That is what you have to do, right? Okay. So I'll first apply to B. F equals ma towards the center. This is important, right? None of the previous questions you got a problem like this, situation like this. So towards the center, what is the force? T2, right? Some students write only T2. But what does the centripetal force means? It is not, when you see a force towards the center, it is not centripetal force in all the cases. But for the previous cases, that was the only force. But here there are two forces acting on B. Two forces, T1 and T2. So what do you have to do? You need to get the always resultant, right? Resultant is what? Towards the center? T2 minus T1. This F means resultant, right? Not just a one force. This is always unbalanced force towards the center. Okay, so the mass is m. I'll write acceleration in terms of r omega squared. The reason for using that is because you can see for both B and C, omega is the same, right? Omega is the same. But if we use V, we will have two different velocity values here. Here the velocity is higher. Here, tangential velocity is higher. So I'm not using V squared over R, right? Even though you use that, you need to correctly assess that, right? But simplification gets easier if you use omega, because for both B and C, omega is the same. Given that this string remains straight, okay, m r omega squared. So that is for B. Then let's see for C. What do you have? Towards the center, we have only T1, right? There's no any other forces acting on this. T1. So the mass m, acceleration, now the radius is 2r, right? Not r, radius is 2r. And we have the same omega. Got it? So this is the first equation. Then you have the second equation. Then you can simplify this. When you divide that, you can see all these terms cancels off, right? T2 minus T1, T1 equals, these cancels off, right? So I'm not going to write them. Here only 2 is remaining, 1 over 2. Cross multiply, 2T2 minus 2T1 equals T1. So 3T1 equals 2T2. So in the answers, they ask it for T2, right? Yeah, T2. So T2 is equal to 3T1 divided by 2. T2 is equal to 3T1 divided by 2. Got it? 3T1 divided by 2. So the answer should be fourth one there. Okay. Answer should be fourth.